Hello dear students. So in our previous class we started discussing about the second law of thermodynamics. So what was the need for the second law of thermodynamics and what were the limitations for first law of thermodynamics? So this is very important. So since so many parameters or concepts which the first law of thermodynamics failed to explain, that laid a platform for second thermodynamics to emerge or to develop. Okay, so first law of thermodynamics was unable to explain various different factors, so that is why there was a need for the second law of thermodynamics. Okay, so first we'll see briefly so what the first law of thermodynamics was explaining about. So the first law of thermodynamics states that the energy can change from one form to another, but the total amount of energy of the universe remains constant. Okay, so this is what the first law of thermodynamics states that. Okay, but the first law of thermodynamics suffers from the following drawbacks. So what are the limitations? We will see one by one. So it does not explain why chemical reactions do not proceed to completion and why spontaneous or natural processes are unidirectional. Okay, so spontaneous means which reaction or which process takes place without an external aid. Okay, so that reaction or process will occur with its own. It doesn't require any heat or temperature or pressure to start the reaction or the processing the reaction. It is a spontaneous. Say for example, a water flowing from higher region to the lower region, or the temperature which flows from higher temperature to the lower temperature, all these are spontaneous. Okay, so we need not to we don't need any external aid to carry out these processes or reactions. But so the first law of thermodynamics it says that energy neither be created nor be destroyed. That means so the flow of temperature from higher temperature towards the lower temperature, that has to pass, that has to reverse. That means from lower temperature also the higher temperature it has to go, but the all the spontaneous and natural processes are unidirectional. That means when water flows from upper area to the lower area, so without any external help, that water will not go back to the upper region, right? We should need a motor. We should need a motor, and we should take the water from the lower region to the higher region. So that is why so that spontaneous and natural process are unidirectional. So then that means how can the first law of thermodynamics says that energy neither be created nor be destroyed, but it can be transferred from one form to the another form. So that is not that much applicable and acceptable. Okay, so this is one reason, one limitation of first law of thermodynamics. And the second one is it does not define the extent of convertibility of one form of energy into another. Okay, so it does not explain that how much of heat has been transferred or how much of water has been transferred from one area to the another area. It just says so heat has been transferred or temperature has been transferred from one state to the another state, but how much amount is or how much extent of convertibility is seen, so that is not explained in first law of thermodynamics. And the third is it does not explain why heat cannot be completely converted into work. Okay, so there is a loss of heat. Say for example, system A and system B. So from A to B the heat is flowing and thereby the work is done. So how much amount of heat has been utilized? All that heat is not converted into work. There is a loss of heat is observed. Okay, so that it will not explain. Okay, so that is why so the heat which has been spread it out or changed in the system or surroundings is not explained in first law of thermodynamics. And the next limitation is it does not explain the direction of natural process. Okay, so this is the same thing what I explained. So it does not explain the direction of natural process. Water flowing from higher region to the lower region is a natural process, but it does not explain why in that particular direction only it is going to flow. So that is not explained. And the next is according to first law of thermodynamics, so heat engine of 100% efficiency is attainable, but our experience says that such engines are not available in practice. Okay, so 100% heat and heat energy is converted into work, so that sort of heat engines are not at all in practice. This is only in the theory we can see it, but in practical we don't have any heat engine which has got 100% efficiency. Okay, so this is the major drawbacks of first law of thermodynamics, and for these reasons the second law of thermodynamics is emerged. Okay, now the statement of second law of thermodynamics can be stated in different ways. Okay, a number of ways we can state it, and to say it in simple words, the second law of thermodynamics is called as law of non-conservation of entropy. Okay, so first law of thermodynamics is called as law of conservation of energy, whereas the second law of thermodynamics is called as law of non-conservation of entropy. Okay, so now let us see how we can define or state the second law of thermodynamics in different ways. Okay, so the first one is all spontaneous process. Spontaneous process means which occurs without an external aid. Okay, naturally the process is going to take place. So all spontaneous process like the flow of heat from hot to cold. Okay, so that is quite common. The flow of heat will be from hot to cold, and diffusion of gas from high pressure to low pressure, means from low pressure to high pressure the gas will not pass, whereas the gas has got the tendency and also the speed to diffuse from higher pressure to the lower pressure region. Okay, or flow of water from uphill to downhill etc. are thermodynamically irreversible. That means, so this is what I said, the flow of water from uphill to downhill is irreversible. That means without any external help we cannot make that flow of water from downhill towards the uphill. Okay, so we need a external force. Okay, so that is why, so we state the second law of thermodynamics as all spontaneous process like the flow of heat from hot to cold and diffusion of gas from high pressure to low pressure or flow of water from uphill to downhill etc. are thermodynamically irreversible. Okay, so this is the first way of stating the second law of thermodynamics, and we can also give the statement like this: the complete conversion of heat into work is impossible without changing the state of any other body. Okay, so we cannot completely convert the heat into work without changing the state of any other body. So this is the second statement which we can give for second law of thermodynamics. And the third one is, it is impossible to construct a machine operating in cycles which can convert heat completely into equivalent amount of work without producing changes elsewhere. Okay, so the same thing, okay, we are explaining it in a different way, that's all. So here also it is not at all possible to convert all the heat completely into the equivalent amount of work done without producing any changes. There should be changes has to take place in the state of a system, and then only the heat is completely converted into the work. Otherwise, so heat is lost. All the heat which has been passed to the system is not going to get converted into work. So this is the another way of stating the second law of thermodynamics. And the fourth one is total energy of the universe remains constant while the total entropy of the universe increases. Okay, so the entropy of the universe is going to increase. We'll see what is meant by entropy in next discussion. In another 5 to 10 minutes we will see what is meant by entropy. Okay, so this is what, while giving the introduction class only, I explained you that so in first law of thermodynamics, a special feature or a parameter or a concept what we are going to discuss is about enthalpy, and in the second law of thermodynamics we are going to introduce and discuss about entropy, and in third law of thermodynamics we will be seeing Gibbs free energy change. Okay, so the second law of thermodynamics says that the total energy of the universe remains constant while the total entropy of the universe is going to increase. And okay, so we will see it while discussing about entropy. Next, what is meant by spontaneous process? A process which takes place on its own accord without any external assistance is called a spontaneous process. Okay, so that is what I told. So there is no need of external assistance for that process to start or to proceed or to continue. Okay, a process which takes place spontaneously or naturally without any external assistance, so that is what is called as a spontaneous process. So, or in other words, a process which can take place by itself under a given set of conditions once it has been properly initiated. So, if necessary, is said to be a spontaneous process. A process which can take place by itself. It doesn't need any external assistance or external help. So, it will undergo by itself under given certain conditions once it has been properly initiated is also called as a spontaneous process. And okay, so these are the two definitions of spontaneous process, and we'll see what are the criteria. Criteria means the conditions of spontaneity. So a process takes place spontaneously to establish equilibrium. Okay, so this is very interesting. So this spontaneous process, why does it happen? Why does it happen without any external assistance? That is because it has to attain the equilibrium. It has to come to equilibrium. Okay, so all the things or substances what we see in our day-to-day life, they attain to or they urge to come to the equilibrium state, irrespective of the examples I can give, not only in chemistry, everywhere in our day-to-day life also we will try to be in an equilibrium state. Okay, so that is the condition of spontaneity, that is a process which takes place spontaneously. It takes place to attain or to come to the or to establish the equilibrium. And the second is if a system is at equilibrium, so then spontaneous process cannot take place. So this is vice versa of the first sentence what I said. If the system is already in equilibrium, so there we will not see any spontaneous reactions or processes that going to takes place. Okay, so if the system is at equilibrium, no spontaneous process is going to take place. And next criteria of spontaneity is free energy of a system decreases during any spontaneous process. Okay, so all the system will have a free energy, what we call it as internal energy. In the same way, so free energy will be associated with all the systems, and that free energy of a system will decrease during any spontaneous process. That is delta G, that is change in free energy. Delta G is equals to it will be negative. Okay, and the fourth criteria, all natural process are spontaneous and irreversible. All the natural process that takes place. So natural process means obviously it is a spontaneous process. That means without any external assistance, the reactions or the process will take place. So all the natural process are spontaneous and irreversible. And the fifth one, In most of the spontaneous process, entropy increases, that is delta S will be equal to positive, and at equilibrium delta S, so S is the symbol which is given to represent entropy. S means entropy. So in first law of thermodynamics, H means enthalpy. So here S means entropy. So delta S means change in entropy will be equal to 0. Okay. And next, so we'll see some examples of spontaneous process. First one, flow of heat from a hot body to a cold body. It doesn't require any external resistance. The flow of heat will automatically start from hot body to cold body. And the second example is expansion of a gas from the region of higher pressure to lower pressure. So this is also one example of spontaneous process. And the next example, flow of electricity from a higher potential point to the lower potential point, is an example of spontaneous process. And dissolution of zinc in dilute hydrochlorics dilute H2SO4 sulfuric acid is an example of spontaneous process. And combustion of carbon is a spontaneous process. Okay, so these are some of the examples of spontaneous process. Next interesting thing what we are going to see in second law of thermodynamics is about heat engine. What is meant by a heat engine? So a heat engine is a device which can do work by using the heat that flows out spontaneously from a high temperature source to a low temperature sink. So that is what is called as heat engine. Heat engine is a device. So what does this device is going to do? So it is going to utilize the heat which has been flowed spontaneously without, see, from if the system is processing, some work has been done in the system, say for example from system A to system B. So the temperature has been transformed from A to B. So there all the temperature has not been utilized for the work to done. So there is some loss of heat. We observe some loss of heat. Okay. So this heat engine, what does it will do is, so it will utilize that heat which has been spontaneously flows out from the region of higher temperature source to the lower temperature sink. So that is what is called as heat engine. Okay, I hope you understood. So when a reaction or when a process takes place from system 1 to system 2, so there we observe a loss of heat. So that loss of heat which has been flowed in that system between those systems, so that heat is utilized to carry out work. Okay, so here we measure how much of heat has been lost. Okay, so that is that particular device is called as a heat engine. Okay, so this is a representation of a heat engine. So here T2, let it be the temperature 2, and Q1 is the work done which has been done. So here a heat engine is there. So this is the sink. So this will be the temperature 2. So here T2 will be the high temperature, T1 will be towards the low temperature. So in between that heat engine is there. So what does it mean? So how much of work has been done here and how much of work has been, or heat has been left out to T1 sink is measured here. Okay, so in heat engine, the spontaneous flow of heat from a source at a higher temperature, so T2 is the higher temperature, to a sink at lower temperature T1 can be used to do work. Okay, so here how much of heat has been flowing from T2 to T1, so that heat is utilized to do the work. Okay, a heat engine takes heat, that is Q2, from the source and rejects unconverted heat Q1 to the sink. Okay, so here Q1 is the heat and Q2 is the heat which has been converted and rejected towards the sink, that is what is called as T1. Hence, so W, that is the work done, will be equal to Q1 minus Q2, that is the converted heat which has been used for the work. Okay, so this is how the heat engine works. And the next is about cyclic process. So as the name itself says, cyclic process means it is a process where system will undergo series of changes, and it will at the end it is going to return to the original state. So that is what is cyclic. Okay, so cyclic means so here the system will start up with a certain series of reactions, and it is going to get changed to various different states, and at the end it will return to the original state. So that is what is called as a cyclic process. So since internal energy is a state function, the net change of internal energy in a cyclic process is a zero. Okay, so internal energy is never lost or never gained. So since it is a cyclic process, all the energy which has been constituted by that particular system will be reserved, and no loss of internal energy will be observed. So that is why in a cyclic process, internal energy, the change in internal energy delta U will be equal to 0. Okay, and next discussion is about efficiency. So efficiency is a measure of a heat engine, how efficiently the heat engine is going to work. So that is measured. So the efficiency of a heat engine is defined as the ratio of the work obtained in a cyclic process to the heat absorbed from the high temperature source. Okay, so that is why when a cycle is completed, so let heat engine absorb Q2 joule of heat from the source at temperature T2 and reject Q1 joule of heat into the sink at T1. So we are going to get the amount of heat converted into work will be equal to Q2 minus Q1. Okay, so this is what we discussed here in the heat engine. The same thing, the amount of work done, W will be equal to Q1 minus Q2. Okay, so here this gives us how much of amount of heat has been converted into work, and the total amount of heat absorbed will be Q2. Okay, so total amount of heat absorbed will be Q2. Hence I can define efficiency. So efficiency is equals to the amount of heat converted into the work divided by total amount of heat absorbed. Okay, so or I can write it in this way. So nu, which is equal to Q2 minus Q1 divided by Q2. Okay, we know that W is equals to Q2 minus Q1. So that is why substitute the value of Q2 minus Q1 here. It will become W divided by Q2, where nu is the efficiency of the heat engine. Okay, so this is how we are going to understand about heat engine and the cyclic process and efficiency. So this is very important. These are the very important concepts which are necessary to understand what is meant by second law of thermodynamics and how the heat change is going to take place in second law of thermodynamics. So to understand all those things, we should be familiar with these three concepts. That is one is the heat engine, another one is cyclic process, what is meant by a cyclic process, and the third is the efficiency. Okay, so with this background, so in our next class we will discuss about what is meant by Carnot's cycle and the different steps which are involved in the Carnot's cycle. Okay, so this Carnot's cycle is an example of cyclic process. Okay, so how here the change of temperature of the source and the sink is measured considering the Carnot's cycle. So everything will be discussed in our next class. Okay, so thank you, dear students.